I guess we can start. Welcome and thanks for joining for my talk. My name is Joran Vinzens. I'm a VoIP developer, so I really write code in Java and for the Asterisk. I'm not so much sales guy or UX guy. Maybe you see on the pictures later that I'm totally not a UX guy. So other than that, I've been around at sipgate for 11 years now, and in the entire time I was confronted with Asterisk, and doing this VoIP business now for longer than 20 years. Reminds me a little bit of how old I am. sipgate is a carrier in Germany and the UK offering services for residential and business customers. In 2013 we became MVNO in the network of Telefonica, so we have mobile phones as well, which is pretty cool. What we are doing right now is pushing forward our PBX part using ARI stuff. So we made the first steps in 2017, made the first prototype, and now from there on we are facing more and more challenges, I would say, with ARI and scaling. And this is pretty much what the talk's about. It's about the architecture of what we came across and what challenges we had to face. It's not so much of a code. I think this is okay. So you will see some pictures and a little bit of code, but not so much about of code. The topics for today now. First, we have a brief look at basics of Asterisk. I think some of you know Asterisk already, hopefully. Then we have a look at AGI and ARI, look what it is and what it's not is. Then we have a look at how these both act together, and then we will have a look at the topic of the talk itself, how to interconnect with multiple Asterisk in a large-scale environment. And after that we will hopefully have time for some questions. So let's start. Well, should we start? I think the architecture by itself. It's normally you have kind of Asterisk as middle-based PBX. You have some clients connected at that. You have a trunk. You have some carriers on between, and everything what is interacting with the phones connects to the Asterisk, which is pretty simple. So you just have one knowledge of everything in the middle. So it's pretty easy. And if you have a call going through, Asterisk knows about this because it's the PBX, right? And so if Alice places a call or gets a call, PBX knows about that. So if now Charlie and David want to call, they can call, so Asterisk knows about both calls unless they hang up, right? So in a large-scale environment, this one central piece is not what you want to have because of many reasons. So we came up with something of that, like that. Fred already talked about a lot of Kamailio, so we use Kamailio for several things like TLS offloading, like user location, like, I don't know. And as well we have the dispatcher module dispatching calls throughout all of our Asterisk instances. And we don't care about which customer is on which Asterisk, so they are spread around like anything. This gives us a great opportunity in terms of, for example, if an Asterisk crashes, not that would ever happen, but if it crashes, it's just a couple of calls from randomly chosen customers which are hung up. And the customer itself asks, okay, the call is dropped, but no other of my colleagues have these problems, so it feels more reliable than it is at the end. So therefore it makes sense to spread out calls throughout all Asterisk instances we have. At the moment we are about 48 Asterisk instances in this setup, so it's quite some. The problem with that is, if now Bob and Charlie want to call, it might hit another Asterisk. So there's no single instance in the middle knowing of all calls, which is good and bad at the same time. And we have pretty much some struggle with that. So one reason or one scenario where we have this struggle is, for example, call pickup. I think call pickup is a widespread term. I think who of you knows about call pickup? Okay, maybe all. Oh. So call pickup, if you get a call and the colleague wants to have the call, you call something, you press something, whatever, and then the call gets diverted to the guy who wants to pick up the call. Which is pretty easy if you have the one instance controlling each and every call, because you can place a call to your PBX, and then the PBX knows, okay, if you dial this extension, I want to pick up the call, so call gets diverted to Charlie in this case. It's not the real good thing if you have multiple asterisks, right? So the first call hits the asterisk 1, for example, the upper one, and the next call to pick up the call is hitting another asterisk. So how do you pick up the calls? So there has to be some logic on top of this basic fundamental thing, knowing of each and every call. And there's, I think, a little bit of story how we solved this. Or we tried to solve this. It's working, so we solved it. And for that, I will show you some dial plan code and AGI stuff and so on. But let's start with the dial plan. I think most of you have seen the dial plan. Okay, if not, this is like a very simple piece of dial plan looks like. So the dial plan is basically, there's an extension, there's a priority in what is counting up as further you go. There's the application, which is doing stuff, in this time log, which is logging. And then you have parameter in what certain scenario you want to log and what you want to log in this case. And this is pretty much each and every application looks similar to that. It's more or less parameter at the end, but it's pretty much that. And this dial plan piece does practically nothing without just logging, makes no sense. So here's a sample of dial plan code which does a little bit more. We log, and then we have an answer application which answers the call, which results in a 200 OK in SIP. Then we play back TT monkeys, and you hear the monkey screaming. And if it's finished, it hangs up. So the fundamental thing in this is you have to remember, as long as an application is running, it blocks further procedure of the dial plan. So as long as the playback runs, it stops proceeding of the dial plan, and only when the playback finished, because the WAV file is at the end, it returns to the dial plan and the hang up is proceed. So this basically is easy for us to script in dial plan, because we have to just write down what we want to have. And as long as the dial plan application is busy, it doesn't return to the dial plan and nothing goes wrong. This is, however, kind of a problem, because the other applications are not involved in that. Therefore, there are some tricks around that. We come later on that. But now we will see in dial plan application this is quite powerful. It's the dial application. I think you have seen the dial application before. And it looks a bit more complex. So this is, I would say, a simple example of it. You have dial for technology PJZip. There's an extension which is dialed on a trunk and some parameter. And the wiki page of the dial application is that. There's a huge amount of parameters you can put on the dial application in the parameter fields just to manipulate how the dial behaves. The problem is there are never enough features. So you always want to do something else, whatever. Earlier we had George here on stage talking about queue, app queue, which is the queue functionality in the Asterisk. And he said, yeah, that's a business logic implementation of the queue in the Asterisk. And if you want to have another queue which behaves in a different way, you have to use something else. And as well here, some external scripts might be handy. And Asterisk provided us with 3 different ways of controlling the Asterisk from the outside. So if you don't want to have to use the dial application or the queue application, whatever. And these 3 are AGI, ARI, and AMI. I personally don't like AMI, so I don't use it, or I tried to not use it, but it's not possible. But for the simplicity, we just talk about AGI and ARI here. AGI is the Asterisk gateway interface, and the ARI is Asterisk REST interface. May I ask who of you has done something with AGI? Okay, quite quite some. Cool. And who of you have written your first ARI application? Oh, that's less. You should do it. It's fun, I guess. So what is that? So here, some people don't know what AGI or ARI is. So AGI, or fast AGI hopefully, is you can trigger an external script or call an external application service, which is quite handy. There's an explanation from Sangoma for that. I quote, AGI is analog to CGI in Apache. AGI provides an interface between the Asterisk dial plan and external program that wants to manipulate a channel in the dial plan. In general, the interface is synchronous, actions taken on the channel from AGI block and do not return until the action is completed. So keep that in mind. As long as you are executing the AGI, it blocks the procedure of the dial plan. And the problem comes in, for example, you want to restart your AGI service. You have an incomplete call on hand, and most likely it's going to drop. You can read that on the wiki page down below the link. It's easy to remember, I think. Not. What are the use cases for AGI? I can tell what the use case is. I can tell you what my use cases are for AGI. It's if we want to have a database lookup, for example, we use fast AGI for that, because Java has a handle for DB lookups and connection pooling and stuff, and telling us if it's correct and so on. So I don't need to write SQL statements right in the dial plan, which is a nightmare, I think. We just call in fast AGI, which is then selecting or inserting or whatever into a database. As well, we have an external LCR, which is giving us the cheapest or best carrier for certain destinations. We make lookups in there as well, and we have an external accounting for our customers, so we call this from an AGI as well. All these things we can just do whenever the dial plan is proceeded. So during call setup and call teardown, we can call an AGI, but while the call is running, we have no dial plan procedure, so we cannot interact with the AGI. In the dial plan, it pretty much looks like this. It's quite simple. You have the AGI application, and it takes one or more parameter. In this case, I really recommend do not use scripts to trigger, just use the fast AGI with the URI-like style. It's so much faster. You can add query parameters to the URL. It's quite handy, then you don't have to interact with the Asterisk later on while the fast AGI is running. But keep in mind, whatever you put in here as, like, for example, the user agent of your phone, this might be tainted. So use URL encoding wherever you can, otherwise you might have some bad strings in your logs, which might call log4j issues, something like that. So keep in mind, this might is a security issue here. So wrap up, AGI is a dial plan application, like anyone in the dial plan as well. It's only proceeded when the dial plan is proceeded, so that's it. During the fast or AGI is running, it blocks in the dial plan and you can't do anything else with the call. And when the call is running, for example, using the dial or Q app or whatever, there's no control you have in the AGI because no fast AGI is running. Again, it blocks the dial plan. So if you do something which takes a long time, it's more likely to have broken calls at the end. For example, you can do a dial application within the AGI application. It's no problem. But then keep in mind you cannot restart the AGI or the fast AGI service without breaking the dial application. So always return as fast as possible from the AGI. It's my personal opinion is the best solution for that. Especially if you have some automated systems for CI/CD. So you just push your code and then Jenkins or GitHub Actions come in place and roll over all the systems. And then you have no clue if there is a call running or not. So you have to handle restarted or restarting services within your dial plan. So much about the AGI. The ARI, the Asterisk REST interface, has two components. There is a WebSocket you have to subscribe to, and then there's a control interface, a normal REST interface, you can call against with REST. So it's pretty simple. If you know anything about web programming, you know WebSockets and REST interfaces, because that's all about. And there's a description what it is from Sankoma as well. I quote, ARI is an asynchronous API that allows developers to build communications applications by exposing the raw primitive objects in the Asterisk, like channel bridges, endpoint media, and so on, through an intuitive REST interface. I will challenge the intuitive part of that. So the first time we had contact with ARI, it was a nightmare. We didn't know anything. So we just fiddled around and looked what's coming out of the WebSocket and had the status application in diagram which triggers ARI and so on. And we practically didn't know anything until we first had a brief glimpse in some libraries doing all the stuff already and had logger output in the Asterisk showing us which is what and what command does what and so on, and how these primitive objects work or interact with each other. It's important to understand how the principles of the Asterisk work, so you understand how ARI is should be used. The diagram application itself, there is a diagram application, it's called Stasis. The Stasis application takes a couple of parameters. The first one is the Stasis application name. It's the same when you subscribe to a WebSocket, you have to give the same string. So Asterisk knows, okay, you subscribe to the Stasis application, and this is the Stasis application you get the events from. Then if you, I don't know, Wireshark or TCP dump or whatever, on the WebSocket, you will find something like that. This is a Stasis start, which is coming out of the Asterisk as soon as a call hits the diagram and you call the Stasis application. This one I took from the wiki page as well. In this case, it's an Hello World application. The type is Stasis start, so it's the first thing you get from a channel you created via REST or via Stasis application. And then there are some information in there where you are in the diagram, what are the caller IDs, additional channel variable if you want, whatever. So it's quite handy to view all these things. Wrap up a little bit. In ARI, you have primitive building blocks, which is, for example, a bridge is a primitive building object, or playback is a primitive building object. Then during the Stasis app is running, it blocks the further procedure of the diagram, but it's not a problem in this case because you can restart your application without losing the call. This is quite handy because yeah, you can just pretty much put your ARI application in your CI/CD and you can deploy whenever you want without losing calls. It's JSON, so you would be able to read it right from the trace. And you can grab and call in log files in there. It's quite good. The primitive blocks, for example, are channels, bridges, playbacks, recordings, and so on. In this talk, I will concentrate on channel and bridges only because it makes things easier. For example, we have a normal call, which is going through the Asterisk, containing two channels, one incoming channel, one outgoing channel, and in the middle you have a bridge. So both calls are connected, and both channels are PGZip channels, hopefully. And so you have media connection between the both channels, and everything is handled by the channel driver itself. There is an app doing practically exactly that, which is the dial application. So if you call the dial application, it uses the primitive blocks as well to realize your call. But instead of using the dial application, we want to use our own application because the dial application is not suitable for us. So we put some ARI logic on there and do whatever we want to do with the call. So ARI is not just the holy grail or whatever. There are some really ugly drawbacks with that. you have to work more than a dial plan, because one line dial plan is very quickly written. You have more components than the Asterisk only, because you need to have this ARI service running anywhere. This is yet another API you have to learn how to work with. So why should you do that? In our case, it's clear, it's flexibility. You can do whatever you want with ARI. You can't do what you want with the dial plan. So with dial plan, you are stuck to what the dial is able to. With ARI, you can do practically whatever you want. Then the question, if I have call control with ARI, why should we use AGI as well? So it makes no sense, right? In our case, it does. For example, you select the Stasis application in an AGI, then you call the Stars application in dial plan, which is looking something like that. So first we have an AGI script, or an AGI, in this case an AGI script, because I was too lazy to write the URL, which is setting a Stasis application string in the variable in the dial plan. Then in our case we have a log message pushing out which Stasis application was selected, and then we simply start the Stasis application with a string or with a variable holding the string for the Stasis application we want to have. So we have, with 3 lines, pretty much any flexibility we want. We can select on what number was called, what user is calling, what time we have, whatever. So you can do on criteria you want to have to select Stasis application without having a dial plan. And keep in mind, there's no good way to test dial plan application. There's good ways to test code, like unit test or integration test or whatever, for Java, for C, for whatever you want to have, or even Go or Python or other script languages. There are test frameworks in there you can test. There's no test framework for dial plan application or for dial plan itself. So in order to do an AGI call or an ARI call, you have to do a couple of things in the right order. So in our case, we have a dial plan procedure because someone's calling our Asterisk server. Then we trigger an AGI, so we get a Stasis application in the dial plan, a variable set with the dial plan application in the dial plan, and then we get a Stasis start on our ARI server. In our ARI server, we have now to do a couple of things, otherwise Asterisk wouldn't do anything. There is not a timeout, nothing, returning to the dial plan if there is no interaction with the channel. So at the end, the 2-minute timeout from SIP hits and the call is rejected or cancelled in this case. So you have to do something. In our case, we want to have an outgoing channel and we want to have audio connection between. So we have to create a bridge. We have to create an outgoing channel. We have to put both channels in this bridge, and then we have to dial the channel. And then there's an outgoing invite to whatever we want to do. So this is a bit more than just a dial application, but you can do it in the order you want. Maybe you want to playback something first for the incoming call. You want to answer the incoming call first. You don't want to have an early media connection between the both channel ends, for example, or you want to playback Rihanna during the ringback time. I don't know. There are a couple of possibilities you have here, and it's just up to you on what you want to do. So this is what I say with flexibility. You can play Rihanna within the ringback tone. Not that anyone wants to hear it. So now we have now the outgoing channel to our phone, but what if we want to have an AGI connection or AGI interconnection for the outgoing call leg? For example, if you want a call to outside your network and you want to have a call to your LCR system and get the cheapest carrier, how do you do that? This is practically what we want to do. The outgoing channel, we want to have an AGI hook. There comes the magic of local channels. Have you ever heard of local channels? One, two, oh, a couple. Okay. Local channels are channels not leaving the asterisk, so this is why they're called local channel. They are traded within the diagram application or within ARI, AGI, like a normal channel, just another type of implementation. You can set a zip header on a local channel for sure, but other than that, you can just handle it like a normal channel. So in a normal case, in the dial application, it would look something like this. And if we introduce now a local channel in between, it looks something like that. So we have our incoming channel, we have a dial application going to a local channel, which is leading to a dial to the outgoing channel. And for the local channel, we can practically do whatever we want to have with what we want, because we have dial plan interaction in there. And in our case, we just drop the dial in the first place and use ARI for that. So the first creation of a local channel is done by ARI. There we have a hook in the dial plan calling dial application, which is calling out zip channel. And on this local channel, we call our LCR system checking for the cheapest carrier. So now we have interaction pretty much of AGI, ARI, AGI, local channel, and outgoing channel. Yeah, we skip that. So now how to connect Asterisk instances. So back to the first question, we had this pickup part. So the scenario is pickup. So we want to have to pick up a call which is on another Asterisk server. Oversimplified picture here, we have carrier where we get an incoming call through any of our Asterisk instances. In this case, the most upper one. After that, we going through Kamailio to Alice. Alice phone is ringing. Now what? In this case, we first selected our status application by AGI. Then we called our ARI service. So we have the call control within a higher level of the Asterisk. It's not, the call control is not in the Asterisk. It's not a dial application, it's something else. Now, Charlie wants to pick up the call. And he hits any Asterisk with that. Again, we call an AGI script to figure out what is this call, where should it go. Okay, in this case, it should be connected to that ARI connection where the other phone or the other call is controlled by. So we have the one knowledge we want to have over multiple Asterisk instances for this one call. And from there on, it's pretty easy. We just have to make an outgoing call from the first Asterisk or for the third Asterisk to the first Asterisk. And then we pretty much cancel the call to Alice and everything is connected, like we want to have. Sounds easy? Isn't. There are some major drawbacks with that. It's very complex, and I don't speak of debugging, I speak of programming that. It's quite complex. And there's nothing ready to use out there. You have to do it all on yourself. As I said, it's yet another API you have to learn, and there have to be this one shared knowledge over the instances. As well, there are benefits in scaling. Doesn't matter if you have 4 Asterisk instances or 400 Asterisk instances, doesn't matter. You always have at max 2 Asterisk boxes involved in the call, because you can make the calls throughout all of the Asterisk servers as you want. It reduces fallback on crash. As I said, in the first place, if one Asterisk instance fails, it's unlikely that 2 calls of one customer are involved in the crash. So it's just a call drop for one person and that's it. For most of the REST developer or web developer, REST and WebSocket is nothing new. So it's quite handy to have something in hand you already know from the technology. And in our case, we enforce boundaries. So the ARI is just for in-call handling and call setup handling. So which device we want to call, which number we want to call, nothing else. All the rest, which status application should be called, or which carrier we want to check, it's all done in AGI. So you can enforce boundaries, that you don't have this one big ball of much you can control. Other than that, there's one major problem with that. We have a single point of failure in there, which is this ARI service. And this is a nightmare, because The Asterisk, you have to connect to the Asterisk via WebSocket. And if you're not connected to the WebSocket, the Stasis application returns immediately to the dial plan and does nothing, because where should it put all the events to? So we have a pretty much tight coupling between ARI services and the Asterisk. What we want to have is something decoupled. So it's not important that the ARI application is connected directly to the Asterisk box. So what we did, we introduced an ARI proxy, which is pushing all the events and stuff to a Kafka, in our case. And then we have our ARI application, which is consuming out of the Kafka. It's not a tight coupling between one ARI service and entire Asterisk fleet. There are, I did a talk on that topic earlier. I think in 2017 I did that. Search on YouTube for my name, you will find it. There are 2 ARI proxies out of the market. It's open source, so you can just download it. I give licenses for free, as Fred said. So there's one from Microsystems implementing NUTS and RabbitMQ, and we have Retail. This is from sipgate doing Kafka. So whether you want to have Kafka or RabbitMQ NUTS, you have to choose which one you want to have. Also, I put a small sample on GitHub on my own GitHub account, so you can see how it would look like if you want to have to build your entire infrastructure on that. Because the ARI proxy is pretty much only an adapter from WebSocket, Asterisk stuff to Kafka, and nothing else. Doesn't control anything, there's no logic in there, nothing. So with that in mind, we have something like this. We have call handling. Now if call comes in from carrier, for example, it goes to Asterisk, we have this not tight coupling anymore between ARI systems and the Asterisk fleet, doesn't matter. And from there we have Kamailio pushing out the calls to the phone wherever we want to have it. So with this scenario, we solved our problem of pickup entirely. And I'm pretty much finished with my talk. So if you have some questions, please.
Yeah, I had a question. Why did you decide to do, is there a reason you did the least cost routing in the AGI script rather than just do it in your ARI app?
Yeah, because there is there are a couple of reasons. Because we want to have this ARI as clean as possible and as small as possible, and you can put everything in there. And you have to organize your code within the ARI script for sure. You can do that by yourself. Yeah, right. At the end, we are trying to push the LCR as far out of the PBX core as possible, and we have some other companies which are connected to sipgate, which should do the least cost routing for us in the future. So it makes no sense to put it right in there right now, just to get it out there again. And so we have just left it where it is already, and we had it already in ARI, in AGI. Sorry.
Yeah. Okay. I get it.
David.
May not be directly related to ARI, but how do you handle blind transfers where...
Not. This is why I want to talk with Sangoma guys, because of transfer at all. Blind transfer, attended transfer is not solved problem yet. Okay, Fred?
Are you doing anything with conferencing?
Yeah, sure, we do conferencing. This was the first product we built on ARI, because conferencing is quite easy. We just have incoming calls, right? So we didn't have to implement all outgoing stuff. We didn't have to implement caller identification, blah, 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 you name it. Just incoming calls and that's it. And with that, we implemented all of what I just introduced. And so you can pretty much call from anywhere. And then it's up to you if you want to concentrate all calls on one Asterisk. Depends on how big your conference is. Might this be a problem? Normally it shouldn't be, because big conferences are crap. But if you have 400 entities conference room, for example, you want to split that to multiple Asterisk instances. So you have one connection between two Asterisks, and in each Asterisk you have 200 connection to the inbound calling clients. And due to connection between the Asterisk, we have the connection, the audio path, everything's fine. Not that anyone would do that, hopefully. So I'm around a little bit, so if you have further questions,